In this tutorial, we'll show you all the steps necessary to perform a generative design analysis. First, we'll import our geometry. Then we'll define material properties. Then we'll define our non-design regions, areas of the model that won't be altered in this optimization. Then we'll apply our loads and constraints. We'll perform our analysis. And finally, we'll view and export our results. So I'll begin by importing my geometry. So I'll choose File, Import Geometry, and browse and select this Bookshelf Design Space Parasolid file. So I'll go ahead and click Import, and now I can see this imported geometry that will serve as the design area or the design space for my optimized geometry. I'll rotate it around so I can see the smaller holes on this side. Now my next step will be to define my material properties. I'll click Create Material, and I'll enter an elastic modulus of 210 times 10 to the third, a Poisson's ratio of 0.3, and a mass value of 7.8 times 10 to the negative sixth. I'll click Assign Material and click to apply this to my geometry. My next step will be to define my non-design regions, or the areas of the model that can't be changed during the optimization. Here I've set the define method to offset, and my offset distance is 2 millimeters. So I select my geometry, select the surface, and I see that I automatically get an offset of 2 millimeters. Again, I select the geometry, surface, and I create this offset. So I've done this for all three of these holes. I'm done creating my non-design regions. My next step is to create my loads and boundary conditions. So here I'll create a force, and I'll enter a value in the z direction of negative 1,000 newtons. For my application region, I'll select this top surface. Then I'll create constraints. So I'll create a displacement constraint on specific cells, and I'll select these non-design region cells. So I've got two of them selected so far. Now I'll go ahead and rotate it and select this third one. So I can see that I have these three regions that'll be fully fixed. My next step will be to go ahead and perform my analysis. So I'll right-click on my bookshelf and I'll place an analysis scene. So I can see that I'm ready to run this analysis, but I need to look at my design studies. And I can see that I need to specify some design settings for my meshless generative design. For my strut density, I have three choices, and I'll stay with medium for this initial run. For my shape quality, I also have three choices, and I'll stay with balanced, although going with preview would allow the run to complete faster. I'll enter a stress goal, in this case of 2 megapascals. With that, I can right-click on this design scenario and choose to run the simulation. Now, with these settings, the simulation may take a little while to run, as much as an hour. In this case, we'll speed it up for the sake of the video. So you can see as the simulation begins, and I can see results start to show up as each iteration is completed. I can see that in the first few iterations, they proceed very quickly and a lot of material is removed. As it progresses, the iterations take slightly longer, and I can see less change between them. So now I can see that the simulation is coming to a close, and it's completing the last iteration, and now it's completed successfully. So now I'll begin my post-processing. I can see on this iteration navigator that I can select any iteration along the way. And this final iteration is selected by default, but I can go ahead and select others and see how this optimization progressed. Now, back here in the beginning, I had a lot more material for each step. I can also animate and play through these iterations and watch this optimization simulation take place. I can see how it arrived at this final result. I can also switch my animation between cycle and bounce to either have it start over or play backwards each time. Then I'll pause my animation and I'll select my final iteration. So this is my final optimized shape, and I can toggle on and off my fringe display where it shows my von Mises stresses. I can also toggle on and off my initial shape. So here I can see my initial design region and my final optimized shape. And with this plot, you can see both in one image. So now for my final step, I'd like to export my design candidate. In this case, I can export it as a .stl stereolithography file. So I'll go ahead and choose a directory and specify a file name and click Export. Then on this export form, I have option to set my units. In this case, I'll choose meters and click Export. And I can see that this file was generated in the directory that I specified. And with that, I've completed this generative design tutorial.